Hello guys, today we go over the 2011 Math Prize for Girls Problem 15. So, the game of backgammon has a doubling cube, which is like a standard 6-faced die, except that its faces are inscribed with the numbers 2, 4, 8, 16, 32, and 64 respectively. After rolling the doubling cube 4 times at random, we let A be the value of the first roll, B be the value of the second roll, C be the value of the third roll, and D be the value of the fourth roll. What is the probability that A plus B over C plus D is the average of A over C and B over D? Express your answer as a fraction in simplest form. So, first off, this is an algebra problem. But after we find a condition, this becomes a counting problem. So, first of all, let's solve the algebra portion. So, what we have to do is we have to turn this into an equation that we can use to solve the problem. So, how are we going to do that? So, A plus B over C plus D is the average, so that means that A over C plus B over D over 2 is equal to A plus B over C plus D. So this means that let's put these under a common denominator. We get AD plus BC over 2CD is equal to A plus B over C plus D. Now let's cross multiply. We get ADC plus BC squared plus AD squared plus BCD. This is equal to 2ACD plus 2BCD. So now let's move everything to one side. We get BC squared plus AD squared minus ADC minus BCD is equal to 0. So what we want to factor out here is that we want to factor D minus C. And so what we notice is that D minus C, this is just AD squared minus BC. So this is very nice. So, sorry, not AD squared, my bad. AD minus BC. Alright, so this is equal to 0. So now, here comes the counting portion of the problem. So let's add a new page. Okay, so now we want these to be equal. So we can separate this into cases. D is equal to C. AD is equal to BC. And a third case where AD is equal to BC and D is equal to C. Alright, so first let's solve cases 1 and 3. So if D is equal to C, A and B can be any number out of the 6. So 6 times 6. And realistically, D and C have to be equal, but they've never said anything about them not having to be equal to A and B. So there's another 6 cases for C and D. So this gives us 216 cases, or 216 ways. Now for number 3, if D is equal to C, that means that A is equal to B and D is equal to C. This results in 6 times 6 for each case, which is 36. Now let's go into case 2, which is AD is equal to BC. So we can do casework on what the common product is. So I'm just going to create another page real quick because we are running out of space. So we want to do casework on what it is. So the common sum, it can equal 2 squared, 2 cubed, all the way to 64 times 64, which is... And so the probabilities of these happening, one of these happening is 1 over 36, probably is 2 over 36, and respectively all the way until 1 over 36, with the middle at 6 over 36, when the value is equal to 2 to the 7. And so this is the case, because as we see, 2 cubed can be expressed as 2 times 4, or it can be expressed as 4 times 2. So there are 2 ways to do that. And for example, for 2 to the 12, the only way to express this is 2 to the 6 times 2 to the 6th. Alright, with that out of the way, we add all of these together, but the issue is that we have to square them because there's also BC that we have to worry about. So squaring them and adding them together, we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. When you multiply this by 2 and plus 36 all over 1296. So this gives us 26 plus 1620 plus 9. So 46 plus 9, 55. So this gives us 146 over 1296. And so our final answer is 146 plus 216 minus 36 all over 1296. This gives us 146 plus 180, which is 326 over 1296. The only common divisor here is 2, so our answer is 163 over 648. Thank you guys for watching. This problem is a little bit long, but I hope you guys enjoyed the video, and if you enjoyed this video, make sure to hit the like button and subscribe. Peace.